Kareb District, who is going to present our grade 10 memo discussion. Ntate Motsamai, over to you.
Good morning, leadership. Thank you very much. Good morning, colleagues. As Ndata Moroto has already introduced me, I will be taking you through grade 10 physical sciences control test for September 2025. If you allow me, sir, Ndate said he will start with a prayer. Ndate
Thank you, Ntate Motsamai. Let me pray. Heavenly Father, in the name of Jesus, we thank you for giving us yet another day. Heavenly Father, lead us, guide us, and walk along beside us. Take us through the wisdom as we are discussing the memo discussion. Let it be very fruitful exercise. In mighty name we pray. Amen.
Amen, Ndate. Thank you, colleagues. Ndate, if we can continue. I don't think we have a lot when it comes to question 1. Multiple choice questions. I haven't seen any comments so far. So this was the multiple choice questions that were agreed upon. Is it visible or should I zoom it a little bit?
You can zoom it a little bit. Yeah, now it's fine, Ntate Motsamai.
Okay. This was the agreement for question 1, multiple choices. I don't think colleagues, unless colleagues have something that they want to add. If we don't have such, I would request that we move forward. (1.8) says, which one of the following represents 1 mole? The number of AWAS molecules in 22,4 decimeter cubed of water at STP. Number of atoms in 6,02 times 10 to the power 23 sodium. C, number of molecules in 34 grams of ammonia. And number of protons in 1 grams of hydrogen. What was the question, Dr. Number? Am I still audible? Dr. Number?
Okay, good morning. Can you hear me? Okay. Good morning. Sorry, I just had to step out so that I'm out of the room. Yes, so the 6,02, we recognize it as Avogadro's number. But if you read it from the top of the options, you read it as a sentence. What is the 6,02? Is it grams? Is it volume? Is it the way that the sentence is phrased is misleading.
I'm not sure if I understand, but if we read it from the top, it says the number of atoms
Yes.
in 6,
6,
02.
times 10 to the power of negative 23 sodium. So with all the other options, it's 22,4 cubic decimeters. It's 34 grams. It's 1 gram. So that number could actually represent anything. It should have read 6,02 times 10 to the power of 23 atoms.
Or sodium atoms.
Yes. I don't know if that makes sense to you guys.
Yeah, I'm hearing you, ma'am. I'm waiting for somebody else to weigh in as well. Because if I'm understanding you well, you're saying that the number of atoms in 6,02 times 10 to the power 23 sodium, the wording is incorrect or is
Yes,
misleading.
Yes.
Okay. Dr. Mawatla, are you still there?
Yes, I'm still here, Daddy.
Did you hear me, Ben? She said the wording is misleading, so it.
The wording should have been 6,02 times 10 to the power of 23 atoms in sodium.
Yes.
Okay. Yeah, I will look into it. Look into it in that.
Okay.
Hello, Miner. Good morning.
Money.
Yes, my name is Mr. Dlamini from Matsirip, Kafentel. Kopa 1.7, Miner. Kopa 1.7.
1.7.
Yeah, so Monana Hobaku acceleration. We are looking for acceleration in intervals of 4 seconds. So we are from 16 to 32 seconds. So the question is asking which one of the following statement is correct about the acceleration between the car between 16 and 32. So in the first option, they say the acceleration of the car remains constant, right? What you're looking at there is that the velocity is constant, and we know that at constant velocity, the acceleration is what is 0, right? Yes. So the correct option would be D as 0. But then I wanted to ask about is the acceleration not constant? In this case, is option A not an option? Because if you had to draw the the velocity time graph of a car that is stationary, of which if it is stationary object, its acceleration is 0. But in this case, yes, we're speaking about a car which is at motion, right? So its acceleration is 0, but it's also, we know that its acceleration is what is constant.
Okay, 1.7, that I think what is important is that what we should note is that the velocity from 16 to 32 is constant, and immediately the velocity becomes constant, we know that the acceleration becomes 0. The acceleration is not constant, but the acceleration is 0 because of the velocity is constant. So therefore, option A will be wrong if you say the acceleration will remain constant. What it is constant there is the velocity. Once then the velocity becomes constant, then the acceleration becomes 0. It does not become constant, but it becomes 0. Thank you.
So, Romania.
Yes, that is coming.
If we had to draw, the reason why I'm making reference to the velocity time graph of a stationary object versus a moving object, both of them, the acceleration is 0, right?
Yes.
If an
Yes.
object is stationary, its acceleration is 0, and if an object it is at constant velocity, its acceleration is 0. If we had to look at a stationary object, we would say that its acceleration is 0, and we can't say it's constant because it is not at motion.
Yes.
But if we're speaking about a car that is at motion, its acceleration not constant. It's 0, yes, but its acceleration not constant. Because even if we had to look at its velocity time graph, can we say the acceleration there is constant?
Okay, I think we ought to first try and understand the difference between remaining constant and saying motion is quantity is 0. Because if we are going to say quantity is 0, is the same as saying it is constant, then we will be stating two different, or we'll be confusing ourselves. For example, let's take this question of velocity being constant. It's constant at 28 meters per second. But if the velocity of the car for the first motion was, for the first part of the motion between 0 to 12 was 0, and then would you still say that the velocity of the car for the first part, it was constant, and then after 16 seconds, it became constant again?
In this case, because the question is specific about the motion between 16 and 32, right? Even if we had to take the motion between 16 and 24, or rather 20 and 28, the velocity would be constant.
Yes.
The acceleration will remain constant.
I need you to understand where I'm coming from. What I'm saying is, let us, for argument's sake, we are changing the velocity of the car. For the first 12 seconds, we are making it 0. Yeah? Not 7, 14, 21. We are making it 0, 0, 0. And then from 12 to 16, there is a change in velocity. What was observed after 16 seconds was that the velocity of the car now changed from 0 to 28 after 12 to 16 seconds. Then the velocity, what was observed, was 28 meters per second. My question would be, between 0 and 12, since the velocity is 0, are we saying the velocity was constant? Just like between 16 and 32, the velocity is constant. Is that what you're trying to tell me?
If we had to look at it in that instance, we'll have to look at stationary versus motion, right? Because if the car is stationary, we are just going to say its acceleration is 0, right? It's an acceleration because it's stationary, and we know that. But when you're starting to speak about constant velocity, because if you look at different points, right? Because in this case, this car, its acceleration from 0, from time 0 until 32. If we were to study its motion, it is increasing from 0 until 16 seconds. Then it's starting to become what? Constant. The acceleration, because it was increasing. And what happened to the acceleration after that? If we had to explain it, or from 0 until 16, until 12 seconds, the acceleration was increasing. And then what happened after that? It remained constant. So the issue of 0 is a quantity in this case, given the A. Because
Okay.
Yes.
Okay, now I understand me. Can we allow, I see hands, can we allow hands before I conclude it? Because I'm just...
Ndatenzie, I see the hand of Ndatenzie.
Thank you. Okay. Thank you, police. Good morning. Can I just make maybe two inputs into the two questions? Let's start first with 1.8. Yeah, with 1.8, we agree that it was a matter of rephrasing that statement. Actually, the B should have been at least 0.602 multiplied by 10 to the power 23 atoms of sodium, or sodium atoms, because it must have a value. The mole has a value. So it was just a matter of maybe rephrasing that statement. But I don't think it is saving a bearing on the correctness of the answer given. It is just that it is going to be the same answer that it is going to be given to that. I think that is the correct answer. Now, When I go to 1.7, colleagues, 1.7 basically it is addressing what usually says about Newton's first law. In Newton's first law, the acceleration remains zero if the object is stationary. That is the first part of it. But as long as the object it is moving at that constant velocity, then the acceleration is still going to remain constant because it is not changing. So at that point, I'd suggest that we accept both A and D because it is addressing what we are having in Newton's first law. Thank you.
Thank you, Ntate. Mokoena, Ntate Mokoena.
MM.
Kgotsong. Yeah, this is my contribution to this. I hear that Ntia is bringing in Newton's laws, but are we not going to cause confusion then when we go back to our learners, when we say now, when an object is moving with a constant velocity, its acceleration is constant, deviating from what is prescribed, that when we describe motion, that when an object moves with constant velocity, its acceleration is zero, because this continues to grade 11 and grade 12 in Newton's laws, in work, energy, and power, and all those things. Because I understand the constant thing, but here I think the examiner was trying to emphasize the fact that when we look at the acceleration of a constant an object moving with constant velocity, which is from 16 to 32 seconds, when you take the gradient of that graph, because this is a typical graph of an increasing positive gradient versus a velocity that goes parallel to the x-axis, whereby when you take the gradient of that curve of the graph, or then it gives you zero. Now, saying it remains constant after that, it's something else, because now you are saying, we are now going to say to learners, when an object moves with constant velocity, it also has constant acceleration. Which for grade 10s will not make any sense, because now we are talking about learners, kids who are just coming into grade physics, and not somebody who has first year physics knowledge or Newton's first law and whatnot. So I would rather move that we keep it as D, the only option.
I disagree. We are not talking of the change in velocity, in the change in acceleration there, I guess. We are just looking at the acceleration, the way it is between the time intervals. Is it changing? Between the given interval, is that acceleration changing?
It's not acceleration, it's velocity.
No, let's talk acceleration. Is the acceleration changing between those intervals? The given interval?
No.
It's not changing. Now, if it's not changing, aren't we saying it is constant?
Ntate, I also would like to concur with Ntate Mokoena when he said, in grade 10, this is where we introduce the concept of acceleration by definition. That is the rate change of velocity. And by virtue of giving learners values of velocity, I believe the examiner, what they had in mind was that the definition of acceleration says it's the rate change. So take the change in velocity over the time interval of 16 to 32. What is the change? The change is zero divided by what is the time interval. Ne? So if the table, for me, personally, I would feel if the table was not provided, then we may discuss the option of saying A or D. But now that they have, yes, now that they were given values there, I think that the examiner, what they had in mind was for them to understand that definition of acceleration.
I agree with you that the examiner had that in mind. But is this object now stationary? The object is still moving. And then as it is moving, is it accelerating, or is its acceleration is constant? That is what we are saying about this table. The time is proceeding, the velocity is still holding the same. But does it mean now at that point that the acceleration is changing or not changing? Because you created it. Now we cannot penalize the learners for what we have created. We know the examiner had this in mind, that he was looking for the zero, but this object, it is not at rest. Because it's not at rest, then the acceleration value when it is at rest, it is zero. But according to this object is still moving. Hence, I was saying, because it is still moving, then it is bringing in what we are referring to in grade 11 and grade 12 as Newton's first law. So it means there is an acceleration, that it is not changing. It is just the constant acceleration that it is there. So we cannot penalize the learners for what we have created. We have to credit the learners for their trail. Thank you.
Thank you, Datenzi.
Thank
Leadership,
you, Dr. MOTSAMAI.
I was requesting that can we shelve it and discuss it later, and then we'll come back to colleagues.
Oh, okay. Before you close it, Dr. MOTSAMAI, I just wanted to check what was the purpose of starting the data from 0 in terms of time to 32 and then velocity from 0 to 28. By looking at the data, it says to me from 0 until 16 seconds there is still acceleration, which is not changing, which is constant. From 0 to 16 seconds, acceleration there is constant. And then from 16 again to 32, are we saying it remains constant?
Which is why I said maybe let's shelve it for later. We have two hands, and Mr. R has been raising his hand for quite some time. Can we just take the last two hands and then we'll discuss it further later?
No, thank you very much, sir. Yes, sir. Can I just add this, sir? When it comes to then my understanding in terms of acceleration, because if an object is moving from rest from 0, then the velocity is 0. And when now I'm starting to increase my velocity, now I'm applying acceleration, I'm accelerating to a certain velocity. Then when it comes to 16 seconds, now when we have a car, then we balance your car. It means with anuj, that it continues to continue moving at 28. Then it means now there's no acceleration. We are not applying anything. You are not accelerating forward. So my understanding for Ellen, I think D, it is the correct one, but because height 16 seconds. The understanding I was accelerating from 0 to 28. Then from 28, I'm no longer now, unless if the term acceleration, maybe we define it at different, because that's the rate in change of change in velocity. Then when it comes to velocity, now we're talking about the change in position. I think for grade 10, that's all correct. Let's stick to number D, please. Thank you, Daddy.
Thank you, sir. I think only one last hand. Is it Sibinda? Is it Mr. Sibinda? Or is it an old hand, maybe?
I think maybe it might be an old hand. PS.
Yeah, I know. I think it's an old hand. Okay, colleagues, we will deliberate on this matter, the two questions, and then it will reflect on the final memorandum what the resolution taken would be. Leadership, can we move?
Yes, and Dr. MOTSAMAI, we can move to, but I think 1.8 is already clear. Let us move to question 2.
Okay, thank you, leadership. In question 2, it says, the tail to head method of representing vector diagrams is one of the most scientific methods to calculate the resultant. Three forces, F1, F2, and F3 of magnitude 60 newtons, 20 newtons, and 30 newtons respectively, act on a box as shown below. 2.1.1 says define resultant. And the MEMO resultant was defined as a single vector having the same effect as two or more vectors together, or the vector sum of two or more vectors acting at a point for 2 marks. It is not part marking. I don't think it's part marking. It's 2 or 0. Question 2.1.2 says, is force a vector or scalar quantity? Explain your answer. The answer is vector for 1 mark because it has both magnitude and direction for 2 marks. So it's 1 mark for vector and 2 marks for the definition of what a vector is. It has both magnitude and direction. Question 2.1.3 says using the tail to head method and a scale of 1 centimeter is to 10 newtons, draw an accurate vector diagram to determine the magnitude of the resultant force acting on the box. The marking criteria says 1 mark will be for force 1 and force 2 drawn head to tail with the correct scale and direction. So that means 1 mark is for both of them. The top 2 arrows, that will be the 1 mark. The first mark will go there. And then the second mark will be for force 3 drawn in the easterly direction from F2 with the correct scale and direction. That would be for F3 here. And then the fourth mark, the third mark will be for the resultant force or net force drawn with the correct direction and scale. The direction is in the westerly direction for 5 centimeters. And then the last mark will be for the final answer of converting from centimeters to newtons, which will be 50 newtons, for a total of 4 marks. Question 2.2 says, if Johnny decides to walk south for 4.5 kilometers and then turn from south to north for 3 kilometers, calculate Johnny's 2.2.1 total distance. So Johnny traveled for that would be 4.5 kilometers plus 3 kilometers, 1 mark, the sum, and 7.5 kilometers, 1 mark as well. And it also says if they rode just 7.5 kilometers only, we award full marks, full 2 marks. Calculate Johnny's displacement, that's 2.2.2. Displacement, that will be the change in position, that is 4.5 kilometers minus 3 kilometers, 1 mark, and 1.5 kilometers south, 1 mark. The south is important because displacement is a vector quantity, so it must have both magnitude and direction for the 2 marks. So if Elena chose direction, opposite direction, making south negative, then north will be 3 kilometers positive minus 4.5 kilometers for 1 mark. And the result there will be negative 1.5 kilometers, which is 1.5 kilometers south. They have to convert it from negative to show that 1.5 kilometers, the negative there represents direction for 2 marks, for a grand total of 13 marks. Over to you, leadership.
Thank you, Ndati MOTSAMAI, colleagues, any inputs on the question 2?
There is, I think, 2 hands that I'm seeing here on my screen. Colleagues, you can unmute and talk. Let's start with Katlego. I think that's Katlego, if I'm not mistaken.
All right, Mania. Good morning, colleagues.
Morning.
It's Mr. Ntaba here. So I'm asking on the 2.1.3, with regards to the conversion of F2, instead of a learner saying it's 2 centimeters, the learner says it's 20 newtons already. So now on the, what about the last, what is this, resultant force, ne? So instead of the student says, the student already converted to what? To newtons. All the forces there converted to newtons instead of centimeters. So now what about the last mark there? So meaning the student was supposed to say the resultant force is 5 centimeters instead of 50 newtons.
Okay, thank you, sir. And sorry for that, Miguel. Miguel, if you go back to the question, it says using the tail to head method and a scale of 1 centimeter is to 10 newtons. Draw an accurate vector diagram to determine the magnitude of the resultant force acting on the box. Meaning the examiner strictly wanted them to convert from newtons to centimeters to draw the vector diagram, and then use this vector diagram, interpret the vector diagram so that they can now say this would be the resultant force. For me, I would say the learner would must forfeit at least 1 mark for that. Because the first mark says it's specific, it says F1 and F2 drawn with correct scale and direction. And if they said 20 there and 60 there, that would be, scale will still be correct. The ratio will still be there, and the direction will also be correct. So I would award a mark there. And saying force 3 drawn in the easterly direction with correct scale and direction, then I will also award a mark there. Now, because they did not use or follow the instruction of the examiner, then they would forfeit 1 mark for the final answer, because that mark for resultant force of 50 newtons would have been allocated here, where we said resultant was 5 centimeters. So it will be 3 out of 4. Leadership?
No, I'm covered in that.
Memantu?
Sorry, it's me again. Just that I'm using a gadget, another gadget. My colleagues, that learner is following the instruction. Remember, in the scale drawing, you are just emphasizing that to represent the 20 newtons, it should be 2 centimeters. So the label, if a learner is labeling it, that the measurement, again, we are looking at the scale that the 2 centimeters must represent the 20. So that means for F2, that learner may not necessarily write 2 centimeters, but the measurement, it is going to be 2 centimeters. At that level, he'll be writing 20 newtons. And at F1, instead of 6 centimeters, he will measure the 6 centimeters, which is what the instruction is saying. But on the label, he will be saying it is going to be 60 newtons. So that learner is following the instruction. It's just that the way he's interpreting it is not the same as what we are interpreting, based on what we have given to the learners. So that learner, in essence, he must get full marks. There is nothing wrong with what that learner has done, because the scale drawing, it was the emphasis and how much of the force should be represented in terms of the centimeters. So that learner must get full marks if he has done the correct scaling and the correct direction.
Thank you, Tatenzi. Leadership?
Yes, I think the difference will come in terms of the scale, but as Ndatinzi is explaining, if the correct scale is just the difference is on the, instead of 2 centimeter, I wrote 2 newtons, then we will still 20 newtons, it will accept it that.
Okay. So we'll just put it in as option 2.
Yes.
Okay, no, thank you, leadership. Colleagues, anything else?
Right. Good morning, colleagues. The first one, it has already been addressed. And then the second one is if the learner did not use the appropriate scale, is that learner going to get 0 out of 4? And then that is on 2.1.3. And then when we go to 2.2.2, some of the learners, they have converted the kilometers to meters. Is that learner going to lose the marks?
Leadership, I think you should come in here.
The the 2.2 question, 2.2.2 question, in fact, the whole of point 2. Remember, colleagues, we emphasize the use of SI units. So if those learners have converted from kilometers already to meters, we are going to credit them because it is what we want. The SI unit for distance, it is meters. So that learner will get, in fact, we must accept it because it is actually how we teach and what we emphasize with the learners. And then to the question that was referring to 313, if the scale it is wrong, there is this rule in marking that it's a repeated mistake. But the repeated mistake, it is only on calculation. But the drawing, as you put it, it should be an accurate drawing. And we have given it. It depends on then which drawing is this learner using. In fact, the scale which this learner is using. So we have to penalize if there is a mistake. Instead of a 6, if we come up with a 3, then that it's a measurement. It's what we want. It's a skill that we want. So that learner need to forfeit. The only thing that we can maybe be lenient on, it is to give on the direction. If the directions are correct, then maybe we can penalize at least once.
All right. It's clear now. Thank you.
All right, Minir. In conclusion, so now the resultant vector there, FR is equal to 5 centimeters. So if the student already said FR is equal to 50 newtons, so therefore we grant the learner 2 marks for that.
I think on the mark, yeah, I think on the marking guidelines, since we have agreed that they are going to get awarded full marks, 1 mark will be for the representation of the vector, and the other one would be for the magnitude there. So I think it will just come with the updated MEMO where the mark allocation will be.
All right, thank you, sir.
Thank you, leadership. Is there any other leadership?
No, I think this one has been answered. If a learner convert the kilometer to meter, will the marks be awarded? So I think we have responded to it to say the learner will get full marks if the conversion is correct. Thank you.
Thank you, Mayatape.
We will continue.
We may continue. Thank you, leadership. Question 3, it says, a taxi is traveling at a constant speed of 15 meters per second in a 40 kilometers per hour zone. A policeman starts driving his car from rest just as the taxi passes him. The police car accelerates at 2 meters per second squared until it reaches a maximum velocity of 20 meters per second. The policeman then continues driving at this constant velocity. 3.1, define the term acceleration. It is defined as the rate of change of velocity for 2 marks. Also accept the change in velocity per unit time. So it's not part marking, that means it's 2 or nothing. Question 3.2 says, determine by calculation whether the taxi is traveling at a speed less than, equal to, or greater than the speed limit. It says for 1 mark, we allocate 1 mark for greater than. Option 1, a learner would convert 15 meters per second to kilometers per hour. So 1 mark for 15 times 10 to the power negative 3 divided by 1/3,600, 1 mark as well. That will give you 54 kilometers per hour, which says the speed of the taxi is higher than the speed limit. It will be traveling at 54 kilometers per hour, greater than 40 kilometers per hour. So that will be 1 mark for that summary there. So the taxi its speed is higher than the speed limit. For option 2, they would convert the speed limit to meters per second, and there that is 40 times 10 to the power 3 divided for 1 mark, and then 3,600 seconds for 1 mark. So we award a mark for that unit conversion there, 2 marks for the unit conversion. And then the speed of the taxi now is recorded at, or the speed limit is 11,11 meters per second, vis-a-vis the speed of the taxi of 15 meters per second. So there would also say that the speed of the taxi is exceeding the speed limit for 4 marks. Question 3.3 says, calculate the time it takes the police car to reach its maximum velocity. 1 mark will go to the formula. Final velocity is equal to initial velocity. Yes, sir?
With regards to 3 point, the previous one. Is it 3.2? So I guess sometimes in class to make learners understand, because again we can see that the conversion here based on, for example, option 2, when you multiply by 10 to the exponent of 3, we are converting the kilometers, and then 3,600 is hours, right? But make a learner understand, you just tell the learner, or if you want to move from meters per second to kilometers, you multiply by 3,6, and the learner will multiply that and do that correctly, right? So in that instance, how with that do I mark the learner correct? If they don't show, if they don't have to show everything, they just multiply by 3,6 or divide by 3,6, depending on the option they choose to go with. And yes, and also say with regards to that, on the allocation of marks, so that it means the learner, right, and then they will realize and they can conclude by writing, right? They can conclude by writing in terms of greater than, without having to show that. And because I can see that there's a mark allocated for greater than, and then there's another mark allocated for now showing mathematically. Whereas the learner can just do it once and explain based on their observation when comparing. Thank you.
Thank you, sir. Colleagues, can you please let me first complete reading out the question so that when we engage on a specific question, we don't waste time on just one question. We can somehow do the whole question. So just allow me to go through the question and finish it, then we'll engage afterwards. I've noted it. I think we'll engage it after I'm done with question 3. Let me just quickly finish presenting it. It says V final, the formula, 1 mark for the formula. Correct substitution of the final velocity, 20 meters per second, 1 mark. And then 1 mark will also be for initial plus acceleration times change in time. And then that will give us a time of 10 seconds for 1 mark. So that will be 4 marks for question 3.3. And then question 3.4, it says calculate which vehicle, the taxi or the police car, is ahead at the time calculated in question 3.3. Now here the examiner wanted learners to check how far is the taxi when time is 10 seconds. The change in position for police car will be 1 mark will be awarded for the formula, and 1 mark will be for correct substitution. And then for the taxi, because it was moving at a constant velocity, that would be the formula for velocity, 15 times 10, 1 mark for the correct substitution. And for comparison, to say that the police car after 10 seconds is 100 meters, is at 100 meters, and the taxi after 10 seconds, it is at 150 meters. So taxi is ahead, 2 marks for the statement that says taxi is ahead of the police car. That would be for 5 marks, for a total of 21. Leadership, can we engage on question 3.2?
Yes, Dr. MOTSAMAI, 3.2, even though I did not hear quite what was the...
Okay, what Minya was saying was that to convert from meters per second to kilometers per hour, if we just look at what we need, these are the things that we need to convert any speed or this velocity that is provided. And if you look at that, that would give you 3.6. So that's 3.6. You either divide with 3.6 or you multiply with 3.6. If you are moving from meters per second to kilometers, I think you multiply it by 3.6. And if you are moving from kilometers per hour to meters per second, you divide it with 3.6. So Manuel wanted to know if that summary was used by a learner. Do we award the full 4 marks?
Okay, so that will mean you will get the 2 marks for that calculation that will do the conversion. And then what will be the last mark for?
The 2 mark will be for the conversion. That conversion will get its full 2 marks. However, if the learner did not indicate this statement here, I think they will forfeit that 1 mark for that statement for the summary.
Yes.
I'm not sure. Maybe you can come in and assist there. Or colleagues, what's the feeling?
Yeah, because when you are looking at it in terms of calculation, the calculation will be right. It definitely will get full marks for that calculation. But now the problem will be the learner will not have written that last statement. Yeah, that will be 3 instead of 4. I don't know, colleagues can come in, but yeah, that's how I will award.
There is a hand, please unmute.
Yes, colleagues, but I think it is going to disadvantage our learners. I agree the learner has done the calculations and the learner can see that the taxi will exceed the speed limit. For the fact that the learner is able to do the conclusion, I think we should not penalize learners for not comparing. I get it, at the end of the day, we are not marking the steps. We just want to see, is the learner able to understand the question asked? The learner managed to convert and the learner managed to conclude. So in my opinion, I don't think we should penalize learners for not comparing. The fact that they managed to see that the taxi exceeds the speed limit, that means this learner can tell the answer, is able to understand the question that we asked here.
Okay, thank you, sir. So you are saying that this 1 mark must be moved somewhere else?
We can say it's 2 marks for the calculations and then 2 marks for the conclusion. The same as 3.4. 3.4.
2 marks for which conclusion?
The conclusion, concluding that the taxi exceeds the speed limit. I get the question asked whether
okay.
it is exceed.
Let me understand you, sir. 1 mark for, because 1 mark has to go to greater than, less than, or equal to. This 1 mark must come there. That was what the question asked.
Yes.
Is it less than, equal to, or greater than? So 1 mark must go to these options first.
Yes.
Before we get to the explanation part. So if they wrote that, we award 1 mark. That means we are left with 3 marks. So we are saying 2 marks would be for that conversion there.
Yes.
That is 2 marks. So
Yes.
the remaining mark, that was the question I'm asking. The remaining mark, do we allow award it to the final answer here? Because already this statement there is supported above there.
I'm not sure if our approach is the same, but now I usually teach learners to calculate first in order to prove whether it's greater than or less than. They calculate first and then conclude after. So this greater than or less than, it must be the final answer. You calculate first and then you conclude.
Okay, so that 1 mark.
Say greater than or less than, it must be 2 marks. Again, saying greater than, less than, or equal, that is the conclusion. You calculate first, and then you get that 54 is greater than 4. You get that 54 kilometers per hour.
Okay, yes. I would suggest that we award this mark, we move this mark to the final answer there. Not to say that greater than or less than or equal to must be given 2 marks.
Okay, all right.
Leadership, are you with me?
Yes, I'm with you.
Okay, so we are in agreement that we award the 1 mark that was for the comparison here. We award it to the final answer.
Yes.
Such that it does, because I feel also they can see that the speed is 54 kilometers per hour and 54 is greater than 40. So it also still supports that comparison there. So we rather just award it there at the final answer.
Yes. And then can I also suggest that 3.4, can you scroll down to 3.4? Now, if you look at 3.4, it is the mark for the formula, the mark for the substitution, again, for calculating the displacement of the police car.
Yes.
And then the taxi is ahead. I would suggest that we remove this mark, 1 mark, to calculating the displacement of the taxi. Agri learners must know the formula V is equals to change in X over change in T. Why can't we allocate a mark? If a learner knows that formula, why can't we allocate a mark for that and then a mark for the substitution? The same way we did with the displacement of the car, the police car. So that the conclusion, the taxi is ahead, then it becomes 1 mark.
Leadership, I believe we award a mark for 1 formula in a question. We don't award multiple marks for formulas.
All right.
Again, it's the same formula, Minir, just that the second one it's with constant acceleration. Acceleration is 0.
Yes. So we only have to award 1 formula. So I believe we'll just put it in there to say any correct formula between the 2.
Yes, that will be proper, MOTSAMAI. And I think also when you move that 3 point, let's go up there, 3.2. When you move that mark up there, you'll also move it for option number 2. And I think
I will also move it. Yes.
I support what the colleagues are saying.
Yes, leadership.
And then the next question was saying for 3.3. Learners can also use a is equals to the change in velocity over change in time. Yes, we agree on that one. And then 3.4, another question that was asked. Oh, it is not asked, that one. All equation of motion can be used that include no. Yeah, I think that is it, that the MOTSAMAI. I don't know, colleagues can raise hands if there's something that I did not talk to.
Okay, okay, leadership. Colleagues, is there any other? I think a member Tsiripe, if I'm not wrong. in that.
Kele nke skolo matsiripe ke skolo ntate.
Okay.
The question here, Minier, actually it is a suggestion. We do notice that you opted to give the conclusion 2 marks. It's just a suggestion. Would it not have been better if maybe you would say those 2 answers would be afforded 1, at least, because I'm afraid these learners may lose that entire 2 marks if they are not concluding well. But it's just a suggestion. Or maybe we would have considered the 100 meters and the 150 meters be given 1, because those are the answer, and then later their comparison being that conclusion. Thank you, sir.
For 3.4 in leadership.
That
we, instead of giving this conclusion 2 marks, we should award 1 mark too.
It's a suggestion, or maybe consider. Yes. How about you consider giving 1 mark for 100 meters and 150 meters, and then the conclusion will get 1. It's a suggestion.
Okay, leadership. And then what would happen if they did not write the correct ones there? Are they going to forfeit that 1 mark?
I'm not sure.
Okay. I think we will come back to it. We'll have to discuss it with leadership here.
Yes, thank you.
Thank you, sir. Colleagues, is there anything else?
Yes, Melia.
Okay, sir.
Yes, can you please consider the picture on our chats? There are options for 3.4.
Okay, Minya. Yeah. Can you please send them to your subject advisor, and so that they can be updated, they can be included when we update the MEMO. Is it okay, Minya?
Thank you, sir.
Thank you, sir. Leadership, can we move?
Yeah, it seems there are no hands. Can we go to questions?
Okay. Question 4 says the velocity versus time graph below represents the motion of a car over a period of time. The car initially moves north. The velocity is a vector quantity and speed is a scalar quantity. Question 4.1 says distinguish between velocity and speed. It says 2 marks will be given to the definition of speed, and speed is the total distance traveled per total time, and velocity is the rate of change of position. 2 marks each for 4 marks. Question 4.2 says describe the motion of the car from C to E. The description says from C to D, the car turns around or moves south or moves in the opposite direction. Constant acceleration or velocity increases from 0 meters per second to 15 meters per second. Hey. That would be from C to D. And then from D to E, from point D to E, we are saying the car travels at constant velocity south in the opposite direction for 3 marks. And then in question 4.3 says, what is represented by the area of the graph or area underneath the graph? And the answer is displacement for 2 marks. Question 4.4, without using equations of motions, calculate the distance the car travels from A to C. That means learners needed to use the formula, the calculated area. So it says 1 mark must be given for any formula for area, correct formula for area. And then 1 mark must be given to substitutions of the correct values from the graph. That would be 5 times 15, 1 mark. And then the last one would be the sum of the areas or breadth, and that would be 37.5 plus 37.5 for 75 meters squared. That's for the 2 triangles. Or if they have summed the breadth for option 2, they would add the breadth together to be 5 plus 5, multiplied 1 mark for that, multiplied by 15, which is the height for 1 mark, and that will also result in 75 meters squared for a total of 4 marks. Question 4.4.2. In 4.4.2 it says, without using the equations of motions, calculate the acceleration of the car between B and C. The acceleration of the car between point B and C without using equations of motions. Then they needed to calculate the gradient of the graph, and 1 mark would be awarded for the formula of gradient, change in velocity over change in time. And then 1 mark will be awarded for the difference in velocities, and 1 mark for the correct time that was calculated there. And the final answer would be 3 meters per second squared south. Here the examiner specifically says 1 mark must be for magnitude and direction. In question 4.5, it says, how does the magnitude of the acceleration of the car between B and C compare to the magnitude of its acceleration between C and D? Choose from greater than, smaller than, or equal to for 1 mark. And the answer says it will be equal to for 1 mark. Then question 4.6, because question 4.6 had a faulty number in there at question, which said, if give a reason to your answer to question 4.4, and there is 4.4. It was supposed to say question 4.5. The examiner felt that this mark or this question must be removed, so it was removed, and the 1 mark was given to question 4.7. If you go to question 4.7, it says, write down the direction of the resultant displacement of the car, and the resultant displacement of the car would be south. So because the learner needed to interpret both motion of the graph, this question has now been changed. It has been awarded 2 marks. Question 4.8 says, use an equation of motion to calculate the velocity of the car at 4 seconds. It says positive marking from question 4.4.2. Equation of motion, the equation that was provided, that will be 1 mark. 1 mark for correct substitution of initial velocity, correct substitution of acceleration times time, and the other last mark will be for 12 meters per second, and that will be north. The slope of the graph is positive there. And for question 4, the total was 28. Leadership, over to you.
Thank you, Ndati. I think we've got questions here. I'm just going to read them and then we'll respond to them. I think will the learners lose all the marks if they wrote velocity, it's a vector quantity, and the speed, it's a scalar quantity? And then for 4.4.1, m squared, is it correct as a unit for distance? This one, 4.4.1, it must be m. They will remove that squared. It must be m. For 4.6, what if the learner wrote because it is a straight line? What note are you noting them, leadership?
Leadership, I'm starting at 4.1.
Okay,
What was
4.1 is, will the learner lose all the marks if they wrote velocity, it's a vector quantity, and speed is a scalar quantity?
Yes, leadership, they will. That will be an extract from what was given to them in the question paper. Velocity is a vector quantity and speed is a scalar quantity.
Okay. The second question, 4.4.1, I've already talked to it, of m squared. Okay. 4.6, what if the learner wrote because it is a straight line?
4.6 has been removed.
Oh, we've removed okay.
Yes.
Thank you. And then 4.8, will the learner get 0 if they did not use the equation of motion?
Can we see the option?
I think Tokwana, Tokwana can come in just to assist us in terms of the option of 4.8.
All right, for 4.8 colleagues, this learner I'm looking at here started first by calculating, it is A is calculating the acceleration at that 4 seconds. And then after that, used the equation A is equals to changing V over changing T. Then this learner managed to get 12 meters per second. This learner did not use equation of motions, but this learner got that 12 meters per second.
Leadership, can you please share that option as well so that we can edit here to look at how the mark allocation would be?
All right, I will send it. And then for 4.6, yes, I understand that it was removed, but for future reference, will we accept that reasoning? Instead of saying the gradient is the same, the learner says it is a straight line.
But all of them, all these parts are also straight lines. All these parts are straight lines. The motion of from A to B, B to D, D to E, E to F, they are all straight lines. The one that we can accept is that the graph is parallel to the horizontal. I think that would make sense to say it's moving parallel to the horizontal. But to say it's straight, all of them are straight leadership.
All right, thank you, Doctor.
Thank you, Media. Moto?
I'm just checking whether I read everything. I think there was also a question on 4.2. Do learners forfeit the last mark if the direction is not indicated for DE, but was indicated for CD? 4.2.
What is it saying?
Do learners forfeit last mark if direction is not indicated for DE?
For DE?
Yes, but was indicated for CD.
The last mark says in the opposite direction. So I'm not sure what do we mean by direction not indicated. Is it south, north, or they did not put in the last part here that says opposite direction? Leadership?
I think the colleague can come in just to assist us there.
Mebela?
Colleagues, with reference to 4.2, what the colleague is trying to say is to say from point C
I'm
to
sorry.
D.
Yeah, I
there
just
is a
had to step
directive.
out to avoid echoes.
Okay.
So if the learner in CD already indicated that the direction changes to south and not continues north, and they say that DE, the learner continues to travel at a constant velocity because the direction doesn't change again, but they didn't say in the southern direction or opposite direction, do they lose the mark?
Okay. So in CD, the learner says that it's moving in the opposite direction.
Yes.
And then from DE,
they just said the car then travels at constant velocity.
okay, no, I don't think they would lose a mark for that. It's still in the southern direction.
Thank you very much. I just wanted to clarify.
Okay. Tabung? Tabung? Okay.
Who are the listeners? Yeah, no.
No, how would I?
We just want to ask 4.1 if the learner on the distinguish he mentioned that speed is a scalar, then you explain, elaborate to say it's a scalar because it has magnitude only.
Mm-hmm. Or they defined what the scalar is and what a vector is.
Define a vector is the velocity is a vector, and they explain why they say in them that both magnitude and they did not take from the statement. They define a vector, they define a scale on 4.1.
Yeah, which, if I'm understanding, because the examiner already said velocity is a vector, so they define what a vector is. And speed is a scalar, and then they define what a scalar is.
Yes, but the question says distinguish.
Yes.
Not define.
Ntate Mogotlo, I don't think it's incorrect, but Ntate Mogotlo, leadership, are you still with us? I think we'll come back to it, Minya. I think we'll come back to it. But for me, I don't think we need to penalize it because it never said do not use that definition. The only thing I see here is that it says they already did not want them to use this difference between speed and velocity. That's the only thing that was limiting here, to say do not tell us that velocity is a vector and speed is a scalar quantity. So for me, I don't think they need to be penalized for stating that, but I will wait for Mr. Moto to come in and weigh in. On that, if you're still around, can you please also weigh in? While that is weighing in.
All right. Yeah, no, I think we have to give marks because we never said they have to define. It's a matter of saying what is it that they're seeing. So let's credit them the marks. If they're saying velocity is a vector quantity, it has both magnitude and direction, and speed has a magnitude only. Let's credit the marks.
Okay. No, thank you, sir. So full marks for that distinction.
But colleagues, we need to be careful because also if RFL velocity is a vector and speed is a scalar, we cannot award a mark because it's already in the statement. They need to give us that that explanation for them to get the full marks.
Yes, that's what I also said. That's also what I said. They cannot say it's a vector and speed is a scalar. But if they define what a vector is and define what a scalar is, then we are saying we will award full marks. Khele?
Yes, Minister.
Yes, sir.
Yeah, with regards to 4.1, right? How does the learner know that they are not supposed to use what they were already given? How do they know that they were supposed to say vector, velocity is a vector and speed is a scale? For us to now do that, if the learner just mentioned that, we're not going to give them anything.
It's written here on the question paper.
How did the learner know that I'm not supposed to repeat that? Because a learner could have seen it, another learner could not have seen it. The learner having this is not as a result of, or is not incorrect, really, whether we feel or not, because we did not say.
It is not incorrect, but it is given already.
So can I just say something? Okay. The learner need to distinguish, not to repeat what it is that it is already said to them. So in them, we have already tell them that we are having a vector quantity and a scalar quantity, which is velocity and speed. They are already there. Now, how do you distinguish them? Whereas we want them to distinguish because we have already given them. So we want more than what it is given in the question. That is the reason why that we cannot allow them to just put it the way it is as in the question paper.
I hope it's clear, colleagues. Nkgopole.
Good morning, Media.
Morning, sir.
Yes. My worry is when the question is not specific, not to include the definition given or the statement given above. So the learner can write the same as an answer. So it's not specific. So I think we should not take that mark from him then.
And also the learner was able to identify.
For question 4.1.
Identify.
You get my point, sir.
Please come again.
Yes. Question 4.1 says distinguish between velocity and speed. But already the statement says the vector, the velocity is a vector and the speed is a scalar. So the question didn't specify to say they don't have to mention the statement given above. So it's open. So the learner can also choose the same definition given.
Oh.
In addition to that, Minion.
Morning, colleagues.
Morning,
Hello?
morning.
How are you?
I'm good, and yourself?
I hope you're fine. So, in addition to that, my point is number one, the learner was able to identify. And then number two, remember these are learners. And then those differences between the velocity and the scale. Velocity is the vector quantity. We turn them from the class. And the question was what? So then designing the learner that mark, for me, I think it would be yes. Because we need to remember these are learners.
Okay. I think we will discuss it with Ntatemoholo as soon as he comes back. We'll talk to Ntatemoholo as soon as he comes back. But from my understanding was that the information was already provided to them. That the first distinction was given to them. or a velocity is a vector and a speed is a scalar. That was the first distinction. Then they say continue to distinguish between the two. Apart from it being a vector and a scalar quantity, what else differentiates them? What else differentiates between velocity and speed? That was my understanding. With the question in mind of avoiding to say define velocity and define speed. Because apart from that, the next difference between them will be their definitions. So I think that was where the question was going. But it will be deliberated and then we'll come back to it. We have Cecile. Can you unmute?
Thank you, colleagues. Since you said that it will be deliberated with the other colleagues, I think I'll just wait for the verdict because my issue was already on 4.1. Thank you, sir.
Okay, thank you, leadership.
Mr. MOTSAMAI and Mr. Moro, yeah. The compromise that we can come up with for that 4.1, if learners, they use that statement as they are, the compromise that we can just come to, it is just to say we accept if they're putting that statement for 2 marks, but they cannot get full marks for that.
Okay. We will discuss it later. There is one hand, Sekhalo.
Good morning, leadership.
Morning.
I was going to suggest what Ntatensia is saying to say learners cannot be given all the 4 marks for just stating that this one is a vector and that one is a scalar, because the examiner has already guided them. Yeah, but if you say this one is a vector and that one is a scalar, the question was expecting for the learners to define. So if maybe we are trying to be lenient, yes, we can just give 2 marks instead of 4. For when the learner is just saying speed is scalar and velocity is vector, we can only give 2, not all 4 marks.
Thank you.
Thank you, David.
Helen?
Yes, Minister.
Yes, sir.
Since you said that if the learner said that vector is a velocity is a vector, speed is a scalar, we just give them 2 marks, right?
Uh-huh.
And then
but it is not yet finalized, you know. It is not yet finalized, but
and then
it will be indicated on the final memo after this discussion.
Okay, then please also indicate then or now what would happen in an instance whereby the learner did not start with the other one is a vector and the other one is a scalar. They just wrote what is in the memorandum to just distinguish in terms of magnitude and direction. So that one will get full marks, four marks. We don't have to say they must have started with vector and scalar first and then this one afterwards.
No, that one would have that one will get full marks, full 4. But the one that says scalar and vector only, that one possibly would understand to say they will get 2 marks out of 4. Possibly.
Yes, that is correct, MOTSAMAI. That is 100% correct, my lead.
Thank you, leadership. Can we move, Mwetapi?
Yes, can we go to question 5?
In question 5, it says define the term concentration. And concentration was defined as the number of moles of solid per cubic decimeter of solution for 2 marks. It says 2 or nothing. So that must be the number of moles of solid per cubic decimeter of solution. Question 5.2 says potassium aluminium sulfate is a is a crystallization chemical compound with a molar mass of 474 grams per mole. Calculate the number of moles of water, X, required for the formation of this compound for 3 marks. And then the marking criteria says 1 mark will be given to potassium aluminium sulfate, molar mass of potassium aluminium sulfate. And then 1 mark will be given to equating the 2 molar masses to the molar mass of the formula. So 1 mark will be for equation, and then 1 mark will be for the correct answer. That is the number of moles of water for crystallization. So that's where the 3 marks go. 1 mark for molar mass of potassium aluminium sulfate, 1 mark for the correct equation there, equating the molar masses, and then 1 mark for the correct answer. Question 5.3. 5.3.1 says calculate a calcium compound consists of 29.4% calcium, 23.5% sulfur, and 47.1% oxygen by mass. Use relevant calculations to determine the empirical formula of this compound for 5 marks. And it says number of moles. For number of moles of calcium, that is 29.4 divided by 40, which is 0.7351 mark. Calculating number of moles of sulfur, that is 23.5 divided by 32, which is 0.7341 mark. And then number of moles of oxygen, that is 47.1 divided by 16, which is 2.943 moles, 1 mark. And then 1 mark will be for of atoms in the empirical. That will be the total of 5 marks. Question 5.3.2, it says determine the molecular formula of the compound if the molar mass of the calcium compound is 136 grams per mole for 2 marks. And it says then 1 mark will be for molar mass of the empirical formula. And then 1 mark will be for the correct molecular formula, which is CaSO4. It's the same as the empirical formula. The ratio there is 1:1 of the molar masses. And the whole question is out of 12. Leadership?
Thank you, Ntate MOTSAMAI. I think we have got, I only see one question, 5.1. Can decimeter cube to be replaced with liters?
According to the examination guideline, I'm not sure, but does this come from the definition from the examination guideline? Does it define concentration in terms of liters? The exam guideline. Leadership?
Morning, Milian.
Yes, sir.
Yes, according to our booklet, it's decimeter cubed or liter.
According to which booklet?
The revision booklet for grade 10.
Oh.
Yes. So we can our 2 marks.
For liter. Okay. So we must include that definition there then. Thank you, sir. Dr. Moroto?
Yes, and that. No, yes, we'll accept it in that. We'll accept it.
Okay. Is there anything else on this question?
No, there's nothing that I think we can move to question 6.
Okay, thank you, leadership. In question 6, it says, The reaction between dilute hydrochloric acid with sodium carbonate is represented in a balanced equation below. And then 6.1.1, what is meant by the acronym STP? And the acronym STP is standard temperature and pressure for 1 mark. Ivan, did I close my question paper? What happened? Ila, can you read the next question? It looks like I closed it when I was changing sides here. And then it says here, what is meant by, if 20 decimeter cubed CO2 gas was collected at STP, calculate the number of moles of CO2 gas collected at STP, and that would be 1 mark for the formula that says number of moles is equal to volume over molar volume, and 1 mark for the correct substitution of 20 decimeter cube divided by 22,4, and the final answer of 0,89 moles. So that would be for 3 marks. And then it says, calculate the initial mass of sodium carbonate that reacted for 4 marks. The initial mass of sodium carbonate that reacted will be the molar ratio between sodium carbonate and carbon dioxide is 1:1. And therefore, the number of moles of sodium carbonate will also be 0,89 moles. This is positive marking from question 6.1.2. Number of moles, or the formula for number of moles, mass over molar mass, what a mark. 1 mark for the molar mass of sodium carbonate. And then the final answer there, that would be 73,87 grams, 1 mark there. That will be for a total of 4 marks. The next question then says, calculate the concentration of hydrochloric acid that reacted if 100 moles of the acid was used. 100 milliliters of the acid was used. The 100 milliliters of the acid that was used, according to the memo there, the answer would be molar ratio between hydrochloric acid and carbon dioxide is 2:1. We award 1 mark for the use of the molar ratio to get number of moles of hydrochloric acid as 1,78 mole. 1 mark for the correct formula, 1 mark for correct substitution into the formula, and then 1 mark for the final answer of 17,8 moles per decimeter cubed for 4 marks. And then question 6.2. Question 6.2 then says, ammonium sulfate. Calculate the percentage composition of nitrogen in the compound. In ammonium sulfate, calculate the percentage composition of nitrogen in the compound for 3 marks. And to the memo there, it says percentage of nitrogen, 2 marks for correct substitution. That would be 2 marks for 2 times 14, which is the atomic mass of nitrogen. 1 mark for multiplication with 100. And then the final answer of 21,21%. That will be for 3 marks. Leadership, over to you.
Thank you. For 6.1.3, I see M is equals to 106 rem per mole.
6.1.3.
Is M. So that means that one 83. It's 106.
It's 106.
Yes.
Or the molar mass.
Yes.
Okay, the molar mass of sodium carbonate.
I think it's just a mistake which will change also affect the answer.
Yeah.
The other question. The other question will be 6.1.
6.1.
Yes. It says STP. The learners only wrote standard temperature pressure. Should we accept it?
Yeah, I think we should accept it. That's STP.
And then the other one is final mark. Can mark descriptors be added as well as ranges for positive marking at chemistry question 6? I think we'll be referring to
leadership.
The question, I think May is referring to 6.1.4. Can she come in and assist there on that question?
Are you in the order ya Thabong, or who is it? Oh, Mebena. Let's start with you.
Sorry, can you just repeat the question?
I think the question emanates from your comment.
Of the final mark, can
The one
mark
for 6.1. Yeah, the mark.
is can mark descriptors be added as well as ranges for positive marking at chemistry question 6?
Yes, depending on the learner's rounding, it's going to affect the accuracy of the answers. So can we add ranges of acceptable answers for quantitative aspects?
Okay, for because of their rounding off.
Yes, and because it's follow-up questions.
Yeah. Now I will include the ranges.
Thank you very much.
Followed by Thabong. Colleague said Thabong.
Morning, William. Kubuling again.
Okay.
Question 6.1.1. Your mark allocation is 1 mark. From the question paper, it's 2 marks.
6.1.1 mark. It should be 2.
2. Yes, sir.
Yes, sir. It should be 2. We'll correct that.
Thank you.
Thank you, sir. Anything else, colleagues?
No, it seems everything is covered in that day. Let's go to are we not done? We're done. Oh no, there's a hand there. Yes, you can talk, leader.
Ms. Hallo? No, my friend.
Ntate Motsamai.
It's an ancestor.
Okay. No, I'll send in Mr. Mutsame. Current network yaka is very wrong. I'll send him the message side.
Okay. Okay.
That's fine.
No, thank you, Ntate Motsamai, for the presentation of the grade 10 memo. And thank you very much, colleagues, for your contribution. It's just a reminder that those that are having clusters, can we please send the registers to the different subject advisors? And thank you very much, colleagues, for your contribution. And the updated memo will be sent with all the suggestions, with all your inputs. And we want to thank you, Ntate Motsamai, for the wonderful work that you have done. And thank you, all of you colleagues. The meeting is adjourned. Thank you.
Thank you, leadership.